Hello and welcome to another video. In this one, we're going to talk about how Linus messed up the Git history of the Linux kernel. Well, he didn't make the commits, but he did merge them, and the ensuing rage afterwards, if you're not familiar with Linus's approach to interacting with people, it's a way to interact with people, I guess. I'm intentionally delaying the start of this video because I'm going to be showing his email contents later, and I don't want to get demonetized. So anyway, let's jump into it and show off what happened and the new option that's added to Git, as well as a sort of evil way that you could make this mistake in your own repositories. Anyway, let's jump into it. Okay, this is the commit. This is the commit that caused all of the rage. Yes, this story is ancient times, but I recently ran into this specific problem while working on rewriting the history of the Joseki repo, which I've already completed. I will be making a video about that soon. But yeah, this repo had this problem as well, and I've fixed the problem in that repo. Anyway, so the commit here looks sort of silly. It's a README at the root of the repository. It has sort of not very useful output. You might actually recognize the structure of this README. This is actually what GitHub will create by default if you tell it, if you check the little box to say create a README for me, it'll fill out the description and the repository name, which is actually what happened here. This README was created by GitHub, but you'll notice here that we are in the Linux kernel and this commit has 0 parents. Now, what does it mean for it to have 0 parents? This means that it is a root commit of a repository. Now, normally when you think of a Git repository, it usually only has one first commit and then everything else extends on in the history from that first commit. But actually, Git repos can have many root commits. And in fact, the Linux kernel, I think, has 4 now. And sometimes this is an intentionally good thing. Like sometimes you actually want to have 2 unrelated histories that merge into a main project, and then the history continues onwards from there. Like the Linux kernel has done this intentionally for adopting, I think the Btrfs thing was done separate from the Linux kernel and then merged in later. We'll show it later because we'll actually show how to find all the root commits, and we'll see this one in that same history as well. But anyway, this was done through GitHub and merged accidentally by Linus, and then a bunch of rage ensued. Like, how did you let me screw up the Git history in this way? You absolute idiot, you buffoon. Linus uses more aggressive terms than that. But let's look at the patch, or at least the discussion of the patch. The neat thing about Linux kernel development is all of the conversation is permanent and archived in various. Oh, I don't want that bookmark. Go away. And this particular patch here ended up getting merged in a kernel driver. I think the funniest part about this, perhaps the funniest part about this, is if we look at the patch of this. Linus is sort of famous for having rage against NVIDIA, and yep, this was done by NVIDIA. So I don't actually remember the chronological of this, but I assume this is after his initial rage. But anyway, yeah. So the proposer of this pull request recognized that their branch was a little messy and they didn't bother cleaning it up, but it was close enough and good enough. Yeah, and they even mentioned that there was this weirdness around some file named README that appeared and then got reverted. Like something strange was going on there. Foreshadowing that was the alternative root commit that ended up being integrated in the end. And yeah, your typical stuff here. He mentions the new root commit. This is the merge commit that introduced it. He also, Btrfs, yeah. So there is actually other roots in the Linux kernel. But yeah. I guess I should talk about why is this a problem? Why is having multiple roots not ideal? One, it's sort of just confusing. Like typically when you think about the history of a repo, you think about it linearly. But this can actually cause problems in repos. So for instance, I have the Joseki archive here. And I guess I'll show you how to find root commits because that is going to be helpful for me to show this other thing. You can find all the root commits by doing git log max parents equals 0. Max parents is just a filter to say I'm looking for commits that have 0 parents, which is a root commit. like we showed earlier in the video. And you can see here, this repo has 5 root commits. And as part of rewriting this history, I actually eliminated 4 of the 5. So there's only a single root commit, which makes it easier to, easier to reason about the history, but also easier to traverse the history. So one thing that I want to show you, for instance, this commit. So yeah. So we know that like this file is introduced in this commit. We know this from looking at the patch of this commit. And one command that I use really often to figure out how things changed in a repo is to do git log and pass -- and then a file name. And typically Git will tell me all of the commits that touched this file and be helpful about figuring out what commits change this in. But we get none here. And this is one quirk of multiple roots in that I think the way Git works is it doesn't actually traverse out each of those other root paths to track this file. And so it's actually really hard to figure out the history of this file. It also has some problems with bisection. Like if you are trying to bisect 2 commits and they happen to be on unrelated histories, or it happens to pick the merge that introduced the unrelated history, sometimes bisect can just fail, which can make it difficult to figure out when something regressed or when something broke. But in general, just like having multiple Git roots can be sort of annoying and kind of painful. Which is why when I rewrote the history of this repo, I eliminated them all. But the, he says this, but it is actually a little, before this Git option that we're going to talk about in a bit got introduced, it was actually really, really easy to accidentally do this because git merge just kind of silently let it happen. And this is the current Git maintainer, the primary Git maintainer, maybe it was always the primary Git maintainer. And so later in this thread, Linus is like, hey, we should not let this happen so easily. And then eventually it led to what I'm going to show you now, which is the option in Git that prevents this from accidentally happening. So if I'm going to clone some repo that I have. We'll use, I don't know, AST pretty. That's the easiest one that we always use. And let's say that for some reason I accidentally added another remote, I don't know, tokenize RT, sure. And this has its own separate history, and we could actually merge this history into a branch of AST pretty. So if we check out origin main to my branch, and then we could merge up, tokenize art. Oh, that's funny. Git merge with no options doesn't do any. Huh. I was surprised it doesn't say like, what do you merge? There must be a default. I bet it defaults to whatever your upstream is set to. But anyway, if we merge this, you'll see that Git produces this helpful error message. And this didn't exist in 2016 when this other root was added to the Linux kernel. This is sort of the fallout of the change here. Refusing to merge unrelated histories. And if we look at git merge help, there's actually a new option here. Let's find the help for it. Allow unrelated histories. By default, git merge refuses to merge histories that do not share a common ancestor. I mean, you can't read the text because it's bottom of my head, but trust. Yeah, and so you can use this option to forcibly merge unrelated histories. So if we do git merge this, obviously it's going to conflict because there are certain files in both repos, but you could resolve the conflicts and then you would have 2 histories merged together. Or at least that's the idea. And so that's the new Git option that resulted because of Linus's rage. Now, I did want to show a slightly evil thing. I have made this other repo, and I'm gonna show you a pull request that looks pretty normal, but it's actually sort of evil behind the scenes. So this is a repo that I just made right before recording this video. That's not what I want to click. I want to click this. And the repo looks pretty normal. It has 3 commits in it, an empty initial commit, and then adds 2 files to it. Did I clone it here already? No, good, perfect. That actually makes this demo better. Test please ignore. My favorite repo name. And there's nothing weird about this history so far. There's only 1 root commit, git log max parents equals 0. You see there's only 1 root commit. Super simple. Oh, I wanted to show you the Linux kernel. Also has multiple root commits. The history is really long and so it takes a lot of time to traverse the history, but This is that weird README commit. This is, I don't remember what Garebus is, but this is the btrfs init, and then this is the actual kernel import from the previous system. I don't remember what it was in before. CVS probably? I don't know. SVN? Who knows? And I actually cloned this using -- filter tree 0, so I didn't have to bring in all of the blobs, which is, this was the only way I was going to be able to clone this without waiting for, I don't know, hours. But anyway, back to test plus ignore. So this history is normal. There's nothing weird about it yet. But I've made this pull request, which looks pretty normal, but I've actually done a pretty evil thing here. So this pull request, adds a file, just an empty F3 file. It has 2 commits in it. One of them looks like the actual work here, and then this merge branch main into PR branch. And, at a glance, you'd probably just look at this and be like, oh, they just merged main, whatever, not a big deal. But actually, this merge commit, oh, wow. Okay, that's even weirder, because last time I did this, GitHub would not show me this patch at all. It just told me there was an error here. So this is actually worse than it was before. So this even looks just pretty normal. Like merge commit shows that file being created. Like this shows that file being created. Oh, this is what I was doing before. We can't display that commit for review. And it does actually sort of give you a hint of this here, but you would never know this unless you clicked through to the commits. But anyway, this second commit here actually introduces a new get root, and merging this pull request, if I go to merge this, and it has to be the merge method. If I did this with if I squashed this, it wouldn't happen. And if I rebased and merged this, it also wouldn't happen because they would, at least I think this would cause them to go on top. I guess I'll test it later. But if I make a merge commit here, this pull request, GitHub didn't notify me at all anywhere that this is doing something nefarious. But now if we look at this repo, fast forward only, max parents, we have 2 get roots now. So terrible prank on merge commits. You can add new get roots sort of on accident. But anyway, that's allow unrelated histories and Linus's rage and this goofy readme.md commit that is in the Linux kernel forever. And hopefully you learned something this. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. And thank you all for watching. I will see you in the next one.